Hi everyone. So I have here a Thomas the Tank Engine Power Wheels ride-on toy that I got secondhand, and it was sort of a last-minute Christmas present of opportunity. And of course the seller says charge the battery overnight and it'll last 30 minutes, and maybe that was true when it was new, but it really doesn't last that long anymore. And hopefully the seller just didn't realize that a lot of people would deplete the battery, let it sit in their garage for a year or two, and not realize that these things don't last. So it runs on a 6-volt battery, and I've cracked the top off here, and it looks like it is just a sealed 6-volt battery inside. I wasn't sure if there would be some sort of fancy electronics in here. I'm not quite sure what this thing is. Let me know in the comments if you know what that is. In any event, I believe this is just a standard 6-volt battery. Some of the larger Power Wheels run on a 12-volt battery. But this is just a little 6-volt one, and by my tests it draws roughly 2 amps continuous when it's running. So I wanted to see what we could do about that. And of course, the obvious solution would be buy another 6-volt lead acid battery that's at least 4 amp hours and splice it into the existing electrical wiring. And that's what anyone with a spot of sanity would do. But I found myself wondering, is there any way that I can use just stuff I have here at home to adapt it to a DeWalt 20-volt power pack? And one of these 20-volt max batteries, this is the smaller size, holds about the same amount of energy. You can see this is a 26 watt-hour battery. Don't compare amp hours because it's different voltage, but 26 watt-hours versus presumably roughly 24 watt-hours on the Power Wheels, because 6 volts and 4 amp hours is 24 watt-hours. So this is roughly the same, a little bit higher, but we would lose this in, we would lose a little bit in conversion. So we'll say this pack, the DCB 207, this little battery is roughly equivalent to the original Power Wheels battery in this thing. And of course, if we use a larger size one, and of course this is not DeWalt brand, this is a knockoff because I'm not made of money, but this would be expected to have much larger capacity, 130 watt hours. So even if we lose a little of that in the conversion, you would hope that that would still be about triple the original battery capacity. So that would be pretty awesome. But of course, there are two big things that we have to figure out in order to properly use a DeWalt battery pack in order to power this thing. For one, there's voltage conversion. I know a lot of people on the 12-volt Power Wheels don't do voltage conversion and just connect a battery pack like this directly and enjoy the extra torque. I don't really like doing that because you're overvolting the motor, but it does potentially work. But this being a system that was expecting a 6-volt power input, there is no way that I'm going to feed it this 20-volt max, which is to say it's an 18-volt nominal power pack. Which is to say it's an 18-volt nominal power pack. I guess DeWalt thought 20-volt max sounded cooler, but it's around 20 volts at full charge and around 18 volts when it's empty. That's way too much voltage for a motor that's expecting 6 volts. So one, we need to handle voltage conversion to get it down to 6 volts or a little higher. And then secondarily, we need a system in place to not over discharge the battery, because unlike lead acids that can take a lot of abuse, even though it's still not really good for them, the lithium batteries in here are going to be more sensitive to over discharge. And normally a DeWalt tool would stop running, would disconnect the battery when it detects that it's gone low and it's no longer safe to use. But I believe that safety mechanism is in the tool and not the battery itself. There is clearly a battery management system inside of here, but I believe that's just for balancing the voltage across the internal cells, and that these connectors here, the B plus and B minus, are connected directly to the array of cells inside of here to output the voltage, with nothing stopping you from doing bad things with it. So those are the two things that we have to figure out. One, voltage conversion, DC to DC conversion, and two, low voltage cutoff, so we don't over discharge the batteries. But if we can sort those out, this would be a massive upgrade to Thomas. And hopefully Sir Topham Hatt would be very pleased to learn that Thomas can run for much longer in a maintenance interval without being recharged. So let's see what we can do here. And so, of course, it being Christmas time, I'm sort of racking my brain to try to figure out quickly, is there any way I can do this with components I already have on hand? So I was thinking maybe one of these cheap DC to DC converters that you can find online for $1 or a bit more if you're willing to wait for it to ship from China, that could maybe do the conversion to 6 volts. And then I was trying to think maybe if I used an LM311 comparator against a voltage reference that I'd squeeze together with maybe a Zener diode or a linear regulator that I have on hand. And you can see that this comparator has kind of seen better days. It got a little discombobulated in shipment, but that's what I have on hand in terms of comparators, at least without getting desperate and using an op amp. And maybe this is a tip 125 Darlington transistor pair that could maybe be used to switch the power on and off based on whether the comparator sees the battery voltage being above or below reference. And I think that might work. The real issue is not the voltage cutoff, it's the conversion. These cheap little DC to DC converters are maybe 2 amps continuous at a stretch, so I don't really like the idea of trying to use that for this application, which is 2 amps. Probably 1.5 amps would be more in the realm of this thing. And you can't really, at least as I understand, you can't really parallel 2 of these together in order to get more amperage, because you would need, well, you could, but you would need additional circuitry to do load balancing, and I'm not sure in my hasty Christmas time activities if I could cobble that together just with components I have on hand. And really that's further complexity. So the next thing I sort of thought of was, well, I have this H-bridge controller from that trash compactor video that I did earlier, and I wonder maybe if overvolting the motor wouldn't be so bad if you pulsed it quickly so that you effectively get the level of current that you would normally get. I don't really like overvolting the motor, but if it's only pulsing high about 1/3 of the time, then maybe I could get away with overvolting it by a factor of 3. So that was another harebrained idea that I came up with. And then perhaps the most harebrained idea that I came up with is This thing is a commercial product by DeSanke, and I don't particularly recommend this model, although I don't think they make it anymore. It's meant to adapt a DeWalt power pack to USB and to give you a flashlight. I don't particularly recommend this model if you do find it, because the USB output is around 4.5 volts. It's really not. It's supposed to be 5 volts USB. And so that might be close enough, but that's really not very good for USB activities. But I thought, I wonder if we can get at the regulator inside here and do something about it. So actually, to be honest, I'm skipping over another harebrained scheme, which is, this is a DC to DC converter that's meant for solar panels that can convert to 5 volts. I looked at the innards of this one, and the DC to DC conversion is done by a semiconductor chip that I don't think gives me any way of changing the output voltage, because I really don't want 5 volts. Maybe I could get away with it, but I really want more like 6 to 7 volts. And I don't think there's any way with the particular chip inside this thing to do it, but maybe we can rejigger the innards of this thing to get it to produce more like 6 or 7 volts. And of course, this is slightly insane. The correct answer would be to run out to the store and buy a new 6-volt lead acid battery and splice it into the system. You don't need a Power Wheels branded battery. That just happens to have a convenient connector and cost at least twice as much. But of course, it being Christmas, the stores are closed right now. So let's see if we can make this work. And so you probably can't read that, but this chip here, this semiconductor labeled 8332G, is the semiconductor chip that handles the voltage conversion. And so pulling up the data sheet on that, this actually does receive feedback of the output through a resistive divider. And I'm thinking that if we can adjust the resistive divider, then maybe we can get this thing to produce a higher voltage, to think the voltage is lower than it really is. So I think just going from the resistor values that R15 and R16 are the resistive divider. So R15 is labeled 473, which would be a 47K resistor, and R16 is labeled 01C, I think, which I believe makes it a 10K resistor. So I'm thinking, based on the resistor values and their proximity to the chip, I can't really trace this very well because there's so much silk screening here blocking my view of the traces, but I'm thinking, based on those values, that that's my resistive divider, R15 and R16. And so I'm hoping that if we can replace R16 with a little bit lower value resistance, that we can make it crank up the voltage a little higher. And this chip is supposedly capable of about 3 amps continuous, so that should get the job done. Now, these being surface mount components, they are a nightmare to solder. Maybe some of you are good at it. I am not. But I'm going to take a crack at this anyway because I'm crazy. And so this tiny little resistor on my fingertip here is a 20K resistor that I salvaged from another device, and I'm going to try to put in parallel with the existing resistor. So you can see here, I have a great effort. I don't know how well you can see here actually, but that is another resistor on top of R16. So after some trial and error, I decided, or what seemed to work, was to take the finest soldering iron I had and put a blob of solder on each side of the existing R16, and then take a soldering hot air gun and use it to warm that solder while I placed another resistor on top of it. And oh my God, it worked. So it's way too big to fit in the battery slot, even if I use the smaller, thinner batteries. But fortunately, there's a big empty space back here where I can sit it. So we'll go with that. And I've labeled it 7 volts so I don't forget and try to plug in a device that's expecting standard USB power. And it worked briefly, but now the USB port is dead, so I assume that regulator chip didn't like operating at higher voltage, or maybe it was damaged by too much current. That's entirely possible. So in any event, this didn't work, and as anticipated, the only logical way to do this is to get a new lead-acid battery from the store. So I hope you enjoyed this video. If you did, please give it a thumbs up. Thanks!